Welcome SYBsc physics student. I am VP Devre, Department of Physics, New Arts, Commerce Science College, Shivagaon, District of Madnagar. SYBsc physics semester 4, paper first, oscillations, waves and sound. Chapter 1, undamped pre-oscillation, and today's topic is problems MCQ and short answer type questions on the chapter number 1, that is undamped pre-oscillations. So here the first problem is a particle performs SHM if its acceleration per unit displacement is 4 cm per second square. What is its periodic time? So this is the problem number first. So we solve this problem here. So first of all, acceleration per unit displacement. Acceleration per unit displacement. So here we have given 4 cm per second square. So therefore acceleration per unit displacement and that is equal to A upon x, that is equal to 4 cm per second square. 4 cm per second square. And here the force constant that is denoted by the K, which is equal to force this divided by displacement. Force divided by the displacement. And here we write force means what? MA upon the x. Okay, that is MA upon the x, and A upon x is the 4, so that is a 4m. Okay, so what is K is equal to? K is equal to 4m. And the periodic time, so therefore the periodic time, this periodic time denoted by the T, that is equal to 2 pi square root of m upon the K. T is equal to 2 pi square root of m upon the K. And so therefore here what's the value of K? K is equal to 4m, that is 2 pi square root of m upon K value, that is a 4m. Okay, so m get cancelled. We obtain 2 pi is under root of 1 upon 4. 1 upon 4. And so therefore it is, when we solve this, then we calculate these all things. So therefore here 2 pi upon 2, and that is equal to here 3.142 second. So this is the value of the T. Okay, so what is its periodic time? So here we obtain T is equal to 3.142 second, and which is the required answer. Okay, so here this is the problem number first. Second, problem second. Problem second. The total energy of a SHM. The total energy of SHM. Total energy of SHM oscillator is 250 erg. 250 erg. If the force constant, if the force constant, if the force constant is 10 dynes per centimeter, calculate the amplitude and period of oscillation. Calculate the amplitude and period of oscillation. Period of oscillations and the mass of the oscillator is 2.5 gram. 2.5 gram. Okay, so this is the problem second. Here the total energy of SHM oscillator is 250 erg. If the force constant is 10 dynes per centimeter, calculate the amplitude and period of the oscillations. The mass of the oscillator is 2.5 gram. Okay, and here we solve this problem here. So given so total energy, so E is equal to 250 erg. Okay, then K is equal to 10 dynes per centimeter, and M is equal to 2.5 gram. Okay, and here we have to find out. So in the next page, so therefore total energy of oscillator, the total therefore total energy of oscillator is given by, so E is equal to what? We know 1/2 Ka square is equal to 1/2 Ka square, and so therefore here E is equal to what to given 250 1/2 What is value of the k? That is a 10, and that is a square. Okay, and so therefore a square is equal to 500 divided by 10. Okay, 500 divided by 10, and so therefore this a is equal to 50. A is equal to 50. Okay, and thus a square is equal to 50. Sorry, a square is equal to 50, and therefore a is equal to 7.07 centimeter. Okay, here one so 50. Okay, and force constant, we know force constant is k is equal to m omega square. Okay, k is equal to m omega square, and so therefore here omega square is equal to k upon m, and that is equal to, what is value of the k? K is the 10, and m is given as a 2.5, and so that is, when we calculate this value is the 4. So therefore omega square is equal to 4, so therefore omega is equal to 2. Okay, omega is equal to 2, and here period of the oscillation, so therefore period of oscillations, that is period equal to 2 pi upon omega, and here 2 pi upon 2, and that is equal to pi, and here we have to know the value of pi, 3.142 second. Okay, so this is the amplitude and the period of the oscillation. Okay, this is the particular answer. This is the problem number 2. Okay, then the problem number 3. So the problem number 3, problem 3. A particle is subjected to subjected to two rectangular SHM. Two rectangular SHM such that the displacements displacement at an instant are given by x is equal to 2 cos omega t plus pi by 4. X is equal to 2 cos omega t plus pi by 4 and y is equal to 2 cos of omega t. 2 cos of the omega t. Find the nature and equation of the path. Equation of the path. Find the nature and the equation of the path. So I again repeat this problem. A particle is subjected to two rectangular SHM such that the displacements at an instant are given by x equal to 2 cos omega t plus pi by 4 and y is equal to 2 cos omega t. Find the nature and equation of the path. Find the nature and equation of the path. So here, for that purpose, the given SHMs are perpendicular to each other. The given SHM are perpendicular to each other. So therefore, x is equal to 2 cos omega t plus pi by 4. X is equal to 2 cos omega t plus pi by 4 and y is equal to 2 cos of omega t. Okay, and so therefore here x is equal to 2, here we write cos omega t cos pi by 4 minus sin omega t sin pi by 4. Sin omega t sin pi by 4 and here we write 2 cos of omega t into cos of pi by 4 1 upon root 2 minus sin of omega t and sin of pi by 4 1 upon root 2. Okay, and that is equal to here root 2 cos omega t minus sin omega t root 2 cos omega t minus sin omega t and that is equal to root 2 cos of omega t minus root 2 sin of omega t. Okay, and so therefore here root 2 y by 2 minus root 2 square root 1 minus y square upon 4, since here y by 2 is equal to cos of omega t. Okay, y by 2 is equal to cos of omega t. So here this equation, that is x is equal to root 2 y by 2 minus root 2 square root of 1 minus y square upon 4, where the y by 2 is equal to cos of omega t. Cos of the omega t. Okay, squaring both sides here. Squaring squaring both sides. Squaring both sides. So here we get x square minus square root of 2xy plus y square upon 2 is equal to 1 minus y square upon 4. So that is here x square minus root 2xy plus y square upon 2 is equal to 2 minus y square upon 2. So therefore x square minus root 2xy plus y square upon 2 plus y square upon 2, and that is equal to 2. X square minus root 2xy plus y square upon 2 plus y square upon 2 is equal to 2. So therefore here x square is equal to x square minus root 2xy plus y square, and that is equal to 2. That is equal to 2. Okay, so here this is the equation of the resultant motion. This is equation of resultant motion, and it indicates the resultant motion is the elliptical, and it indicates that the resultant motion is a elliptical. Resultant motion is a elliptical. Okay, so this is the problem number 3rd. Okay, resultant motion is a elliptical, and then here we have to take some here MCQ type of the questions. MCQ type of the questions. Okay, the next is the MCQ type questions. First, equilibrium position is also called as equilibrium position is also called as equilibrium position is also called as dash dash dash. Okay, the optionals A, B, C and the D. A is extreme position, then unstable equilibrium position, then mean position, and the stable equilibrium position. Stable equilibrium position. So in this chapter, the first topic is that is the types of the equilibria, in which we studied the theory and concept of these equilibria, types of the equilibria. So therefore, here the equilibrium position is also called as, the four options are: extreme position, not correct; unstable equilibrium position, not correct; mean position, okay; stable equilibrium position, not correct. So therefore the answer of this question, which is the C, that is the mean position. Okay, so this is the first MCQ type questions. Second type: the smallest time interval, the smallest time interval after which the oscillation repeats itself is called dash dash dash. The options are: first option, phase of oscillation; then time period of oscillation; amplitude of oscillation; and energy of oscillation. So what is the answer? And the correct answer is the B, time period of the oscillation. Okay, time period of the oscillation. Then the third MCQ type question: Lissajous figure are used to compare. Lissajous figures are used to compare dash dash dash. Options are: frequencies of two DC voltage, two DC voltages; B, amplitude of two AC voltages, amplitude of two AC voltages; C, amplitude of two DC voltages, amplitude of two DC voltages; and D, frequencies of two AC voltages. Okay, and here the correct answer is the D, frequencies of the two AC voltages. Frequencies of the two AC voltages. Then the fourth MCQ: if the SHMs are in a phase, if the SHM are in a phase, then theta is equal to dash dash A, B, C and D. If the SHM are in a phase, then theta is equal to, first that is a pi by 2, then 0, 3 pi and the 2 pi. Okay, so if these two SHMs are in a phase, then theta is equal to, so the correct answer is the B, that is a 0, which is the correct answer. Okay, then here next 5 MCQ 5. The equation x dash is equal to, the equation x dash is equal to, x prime is equal to a minus x is dash dash dash. Options are, first is the parabola, B is the circle, C is the ellipse and D is the straight line. Parabola, circle, ellipse and the straight line. Okay, so the answer, what is correct answer? Correct answer is the A, that is the parabola, that is a parabola. Okay, so these are the MCQ type questions, and the next is the short answer type questions. Short answer type questions. Okay, and here we write the answer in the tutorial notebook. So tutorial first, chapter first. Okay, so first question 1. Question 1. What is periodic motion? What is periodic motion? Okay. Question 2. Define equilibrium state. Define equilibrium state. Question 3. State various types of equilibria. States various types of equilibria. Question 4. What are Lissajous figure? What are Lissajous figures? What are the Lissajous figures? Question 5. State any two application. State any two applications. Any two applications of Lissajous figures. Lissajous figures. Question 6. Define angular simple harmonic motion. Define angular simple harmonic motion. Define angular simple harmonic motion. Question 7. What do you mean by restoring force? What do you mean by restoring force? Question 8. What is the stable equilibrium? What is the stable? What is the stable equilibrium? Okay. Question 9. Define linear simple harmonic motion. Define linear simple. Define linear simple harmonic motion. And last question, question 10. What is neutral equilibrium? What is neutral equilibrium? Okay, so these are the 10 questions. Okay, and we here end this chapter number 1. So you must write the answers of these questions in your tutorial notebook, and when that is a date of this checking of the tutorial will be notified later. Okay, so you must write the answers of these questions in your tutorial notebook. Okay, so thank you all of you.